So what if I told you that you could use the echo of a single exploding star to measure the entire universe? It sounds like science fiction, right? Well, today we're going to dive into the incredible story of how a team of scientists did just that, pulling off what everyone thought was an impossible cosmic prediction. Okay, so picture this. It's 2015, and a team of scientists does something that's, well, it's supposed to be impossible. They predicted the exact time a supernova would appear. We're talking about the explosion of a star billions of light years away. This had never been done before. So of course, the big question is, how in the world did they pull it off?
All right, first, let's get on the same page. What is a supernova? It's basically the most spectacular, violent death you can imagine for a really massive star. When it runs out of fuel, it collapses on itself and then just boom. It rebounds in an explosion so ridiculously powerful it can literally outshine its entire galaxy. And remember, that's a galaxy with like 100 billion other stars in it.
Yeah, and the thing about supernovae is they are notoriously unpredictable. I mean, they're incredibly rare. You might get 2 a century in a galaxy like the Milky Way. To give you some perspective, you've probably heard of the star Betelgeuse, right? It's this huge red giant that's basically prime real estate for a supernova. Astronomers are pretty sure it's going to blow any day now. You know, sometime in the next 100,000 years. So yeah, for us, that's pretty much forever.
But despite those absolutely insane odds, this team of scientists went and confidently requested time on the Hubble Space Telescope, which is a huge deal, by the way. They said, point it at this distant galaxy, SP149, because we predict a supernova is going to pop up there in late 2015. I mean, the sheer confidence. And you know what? They actually got the telescope time.
So the clock is ticking. The observations begin. October 30th, Hubble swivels its giant eye to the exact spot in the sky. And nothing. Absolutely nothing. No new bright star, just space.
Okay, maybe they were just a little off. 2 weeks later, they try again, November 14th. Still nothing. The cosmic firework they promised was a total no-show. You can just imagine the tension building.
But then, December 11th, they take one more look and jackpot. Right there, exactly where they said it would be, a new point of light just flares into existence. The impossible prediction, it actually came true. Which, of course, brings us right back to the big question. How? How on earth did they know? Was this the luckiest guess in the history of science? Or was there something else going on entirely? And here's the twist. It's absolutely brilliant. The secret is they weren't predicting a new supernova at all. They were predicting a replay. You see, they had already seen this exact same star explode a full year earlier. And get this, they saw it in 4 different places all at once.
Okay, so how is that even possible? To understand this cosmic magic trick, we need to dive into one of the wildest ideas in all of physics, something called the cosmic lens effect. It's a phenomenon where gravity itself can bend light and create these massive mirages across the universe.
It all goes back to Einstein's General Relativity. He figured out that really massive objects, we're talking entire clusters of galaxies here, don't just sit in space. They actually warp the fabric of space-time around them. So light from a really distant object like our supernova has to travel through this warped, curved space. And as it does, its path gets bent, almost exactly like how light bends when it passes through a magnifying glass.
Now, depending on how everything lines up, the thing you're looking at, the massive thing bending the light, and us here on Earth, you get different effects. If it's a perfect straight line, you can get this beautiful, complete circle of light called an Einstein ring. But if things are a little offset and the lensing galaxy is kind of elliptical, you can get something called an Einstein cross, where the light is split into 4 separate images. And that is exactly what the Hubble telescope saw back in 2014, 4 distinct images of the very same supernova.
But hold on, because it gets even weirder. This cosmic lens didn't just split the light into 4 different spots. It also made the light from each of those spots arrive at different times. So they weren't just seeing the same event in different places, they were seeing echoes of it, separated by days or even weeks.
So why the delay? Well, it happens for 2 main reasons. The first one is pretty straightforward. Some of the light paths around that massive galaxy cluster are just physically longer than others. Simple geometry. But the second reason, this is where your brain starts to melt a little. It's a direct consequence of general relativity. Gravity itself actually slows down time. So the light that travels deeper into the cluster's gravity well is literally moving through slower time, so it arrives later. This amazing effect is called the Shapiro delay.
Okay, so once the astronomers understood this, they realized they could turn this whole crazy phenomenon into a predictive tool. See, they had already been studying the specific galaxy cluster for years, so they had really detailed maps of where all the mass was. And they could see other lensed, smeared-out images of the supernova's home galaxy. So they asked the critical question, okay, if we saw the supernova in these 4 spots in 2014, when should we expect it to show up in those other lensed images of the galaxy?
Using their models of the cluster, they made 2 pretty wild predictions. First, they calculated that one image of the supernova must have already passed us by. Way back in 1995, we just missed it. But second, and this is the important one, they predicted that a 5th image, taking a much longer path around the cluster, was due to arrive about a year after the 4 they saw in 2014. And that, my friends, is exactly what happened. It was a massive confirmation of their understanding of gravity and spacetime.
So look, this is an incredible test of general relativity, for sure, but the story doesn't end there. The implications get even bigger, because this one supernova, which they nicknamed Supernova Refsdal, it offers us a brand new way to tackle one of the biggest, most vexing problems in all of science today, a problem that some people are calling a crisis in cosmology.
At the very heart of this crisis is a single number. It's called the Hubble constant. And all it is, really, is a measurement of how fast our universe is expanding. It sounds simple, but it's one of the most fundamental numbers in all of science. It tells us the age of the universe, its size, and even its ultimate fate. And here's the problem. Our best measurements of it don't agree.
Yeah, it's a real head-scratcher. We have 2 main ways of measuring it, and they give us 2 different answers. One method, called the distance ladder, looks at stars and galaxies in the universe closer to us, and it gets a value of about 74. The other method looks way back in time at the faint glow of the Big Bang, and it gets a value around 67. Now, those might not sound that different, but as our measurements have gotten more and more precise, those 2 numbers have stubbornly refused to overlap. They are statistically, fundamentally different. And this isn't just some small measurement error we can brush aside. It's a major discrepancy that suggests there might be something fundamentally wrong with our entire model of the universe. It's so serious that one leading astrophysicist, Joseph Silk, literally called it a possible crisis for cosmology.
And this is where our amazing supernova comes back into the picture. Remember those time delays between the different images? Well, it turns out the length of those delays depends on 2 key things. 1, how mass is distributed in the lens and galaxy cluster, and 2, you guessed it, the Hubble constant. This gives us a completely new, totally independent 3rd way to measure the expansion of the universe, an idea that was actually proposed way back in 1964 by an astronomer named General Refsdal.
So the big question is, what did Supernova Refsdal tell us? After all the calculations were done, the number they came up with was around 64. Now, it's important to say, the margin for error on this one measurement is still pretty big. But that number is much, much closer to the value we get from studying the early universe, the 67 number. It's not a final answer, but it's a really tantalizing new clue in this huge cosmic mystery.
I mean, when you just take a step back and think about it, this whole story is completely mind-bending. It really forces you to rethink what space itself even is. It's not just this empty, passive background. It's an active player in the cosmic game. It bends, it warps, it even slows down time, creating these ghostly echoes of a single event that can appear to us decades apart.
And the real takeaway is this. Encoded inside these strange cosmic distortions is profound information about the fundamental rules of our universe. This one single exploding star gave us a whole new way to measure the cosmos. It really makes you wonder, doesn't it? What other incredible secrets are still out there, hidden in plain sight, just waiting to be revealed by the next cosmic mirage?